Welcome everyone, I'm Adam. In this problem, we're going to find the equation of the tangent line to the parabola given by our equation y equals negative 2x squared, which intersects at the point negative 1, negative 2. Now to help us visualize this, we've graphed this information over here. So we have our parabola, y equals negative 2x squared, which based on the equation we know as vertex at the origin, and it's going through point negative 1, negative 2, and by symmetry, also through point 1, negative 2. So we have our parabola and the tangent line graphed here intersecting at that one point, negative 1, negative 2. So again, what we want to do is find the equation of this tangent line. And so the equation of the line, essentially, what we're trying to do is we want to find this information. The equation of the line, y equals mx plus b. So we need the slope of the line and b, which is the y-intercept, which we've kind of sketched here. As the line goes up, it intersects the y-axis at some unknown point with coordinates, say 0 and y-intercept or y-value b. So if we can find that, we can plug in b, but then also if we can find that coordinate, we have a second point, and with those 2 points on the line, this unknown point and our point negative 1, negative 2, we can find our slope m, completing the equation of the line. So let's begin. All right, so what we want to do is first try and help us find what this b is going to be. Now, what we're going to start with is looking at our equation of the parabola, which shows y is equal to negative 2x squared. Okay. And with this, we're going to transform this a little bit more into the standard form where we can see what our h, k, and p will be. And why we want those is what we're going to use as a fact. I'm not going to draw it in yet because I don't know where the points are. But a fact when we have a line touching a parabola is that the distance from the point of intersection to the focus, which will be somewhere about here, and then the distance from that focus up to the intersection on the axis are going to be the same. And we can use that, like we said, to find this value of b. So first, like we said, let's write this in its standard form. So what do we have? Well, we have, and we're going to rearrange this. So we have negative 2, and x squared can be written as x minus 0 squared is equal to, say, y, or quantity y minus 0, since we know that's what our vertex is. And we'll divide both sides by negative 2. So we have x minus 0 squared is equal to, say, negative 1/2 times y minus 0. And to complete this, all right, so we have negative 1/2, but we want to write this as 4 times p. So negative 1/2 could be written as 4 times, say, negative 1/8. 4 times negative 8 gives us a negative 1/2 times y minus 0. So like I said, we already know that h and k are 0, but here we have the value of p. And why is that helpful? Well, like we said, what we want to do is find our focus. So our focus, right, is going to be at the point h, say k plus p. Okay? And so that's at the point h we know is 0. Right? K is also 0, and p is negative 1/8. So k plus p is negative 1/8. So coming back over here, like we said, here's our focus. Put this point here in at 0, negative 1/8. And so the distance from our point of intersection, which we'll call, say, D2, and the distance from the focus up to the line intersecting the axis, we'll call that D1. So right off the bat, we can get an idea of what D1 is going to be. So D1 is whatever distance B is, right, from the origin up to B, plus 1/8, which is the distance from the origin going down. So D1 is going to be B plus 1/8. And what we know is that D1 and D2 are equal to each other. So how does that help us? Well, if we can find D2, we can set that equal to D1 and then solve for B. And then once we get B, we get that extra point, and with the extra point, we get our slope. Now D2 will be easier to find because that's just a distance between two known points. So D2, right, just the distance between these 2 points, which just from algebra, the distance between 2 points is found by taking x2 minus x1 squared plus y2 minus y1 squared. And so that's going to be equal to the square root. We'll take our second point, is the focus here, 0, -8, -1/8. So x2 will be 0 minus the x-coordinate of our first point minus -1 squared plus y2, the y-coordinate, -1/8 minus y1 minus -2, say quantity squared. Okay, and what do we have? All right, so we have minus -1, which is just 1 squared, so we have 1 plus, okay, so -1/8 plus 2, right? 2 is 16/8, so -1/8 plus 16/8 is, say, 15/8 quantity squared, which will be equal to the square root of 1 plus 225 over 64, and 1 is 64 over 64. So 64 plus 225 gives us, say, 289 over 64, which, taking the square root, will give us 17 over 8. Okay, again, how does this help us? Well, we know that this is D2. As we said, D2 is equal to D1, which we said is equal to B plus 1/8. So 17/8 is equal to B plus 1/8. Subtracting 1/8 from both sides, we get 17/8 minus 1/8 is 16/8, or 2 is equal to B. Okay, now we're almost there. Like we said, we have our equation, y equals mx plus b. We have our b, now we just need our m. And the m, the slope, let's see here. Right, is just subtracting the y values of the 2 points. So we'll take our intercept point 0b, or 0, 2, is like our y2. So we have 2 minus the y-coordinate of our first point, so 2 minus -2, and then x2, x-coordinate of our second point, 0 minus the x-coordinate of our first point, so 0 minus -1. And so what does that give us? 2 minus -2, positive 4, 0 minus a -1 over 1, so our slope is equal to 4. And finally, putting it all together, the equation of our line is going to be y equals mx plus b, or equal to 4 times x plus 2. So there's the equation of the tangent line intersecting the parabola at the point -1, -2. Thank you very much.